Welcome to U4L1 Intro to Similarity. So two geometric figures are similar, and the way we show similar is this symbol right here. If all pairs of corresponding sides are proportional, that means the ratios of the corresponding sides are equal, and the corresponding angles are of equal measure. Okay, a similarity statement is a way that we can state that two figures are in fact similar, and that means that the corresponding vertices are in the same position, and then that similarity symbol is going to be in between your two figures or your two triangles, whatever the case is. So looking here at these two triangles, QPR and XYZ, these are similar. So if we look at those two relationships that are above, we can kind of notate what that really means here. So what that means is that the corresponding sides are proportional. So I'm going to label these sides real quick. So we're going to do let's do lowercase. So A, B, C, and then D, E, F. Corresponding sides are proportional, meaning if I make a ratio of one side to its corresponding side, that's going to be equal to a ratio in the same order. And that's going to be true for all the corresponding sides. So in this case, 3 different sides. So the corresponding sides. So let's look at the sides. So if I look at A, for example, which corresponds with D, I know that because I can look at the angles. This has 2 arcs and 1 arc, 2 and 1. Okay, so those two sides are corresponding. So if I do my ratio of A to D, that's going to be equal to the ratio of B to its corresponding side E, which is equal to the ratio of C to its corresponding side F. Okay, notice that on top is ABC, and all of those came from the same triangle. Same with the bottom, DEF, all of those came from the same triangle. Okay, so that's the first part of the definition. The second part is that all the corresponding angles are equal. Okay, so I'll just use congruence here. So looking at angle Q, for example, angle Q, so angles. So angle Q is congruent to its corresponding angle. So Q corresponds with X. So angle Q is congruent to angle X. Okay, also angle P is congruent to angle Y, which it corresponds with, so P and Y. And then same for the third pair of angles, so angle R is congruent to angle Z. Now a similarity statement that we could use here, a similarity statement that we can use here is going to, again, have that similarity, that symbol, that means similar, right, in between. We can write our first triangle in any order we want. I'm just going to go QPR. QPR, that's the triangle on the top, is similar to triangle, and then find the corresponding vertices, right? So Q corresponded with X, and then P with Y, and then R with Z. So we're going that same order. So QPR, and then XYZ. So triangle, XYZ. And that's what a similarity statement might look like. Okay, so taking that intro and that idea, let's go ahead and apply that to some examples. So example 1 says, show that the triangles below are similar by calculating the ratios of corresponding sides and proving they are all equal, then write a similarity statement. Okay, so how do I know which sides are corresponding, right? This is what you do. Look at the size of the sides. So if you look at the first triangle at the top, what is the longest side? The longest side is the side with the biggest number, right? Of course, that's US. That's 36. The longest side in the other triangle is 120. That's PR. Those correspond. Let's look at the shortest side in the first triangle. So between 27 and 30, 27 is shorter. And at the bottom, that's going to be RQ of 90, right? So we have the longest side, we have the shortest side, and we have that for both triangles. So let me just notate that. We have the longest, we have the shortest, and then we have the one in the middle. Okay, I'll just put a little squiggly line for that one. 30 and 10. So those are not the shortest, not the longest, right? And so that's how we know which ones correspond. Now, in order to figure out whether they are similar, we need to make our ratios in the same order. So no matter how you do it, you need to do it in the same order. Look at the smaller triangle, look at the bigger triangle, just be consistent. So if I, for example, want to start with 36, which corresponds with 120. Those are the longest sides. That's fine. Okay, I can figure out what that equals. I can use a calculator to divide those, 36 divided by 120, and I can actually just write down what it equals to. So 36 divided by 120, I'm doing it in my calculator, is 0.3. That's fine. I need to do that for all of them. I need to do wherever 36 came from, all of the numbers in that triangle need to be in the same spot. They need to be on top. So now I can go to 27, for example. Okay, so go to 27 over 27 is the shortest. That corresponds with 90. 27 divided by 90 is going to give us 0.3 again. And then we can actually do that one more time. We can do that one more time with the last pair of sides, which is going to be 30 and then 100. Okay? So 30 divided by 100, which is 0.3 again. So all of the ratios are equal. So we have just shown that they're similar by calculating all the ratios. All the ratios are equal. So they are similar because all ratios are equal. Okay, all ratios are equal. Now our similarity statement. So it doesn't matter how we write our first triangle. We can write it any way we want. So triangle, I'm just going to write TUS for the one on top, is similar to triangle. Don't forget the second triangle. A lot of people forget that. Okay, don't forget that. So triangle TUS is similar to triangle. And then what we need to figure out what corresponds. So T is across on the longest side, which is 36. 36 corresponds to 120. So across from 120 is Q. So that means that Q and T correspond. They go in the same position. So that means that it's going to be triangle Q. Now for this next part, there's a few things you can do. So to figure it out, you can look at U and do the same thing. U is across from the shortest side. Okay, that's 27, which corresponds to 90. What's across from 90 is P. So P goes next. Another thing you can do is follow the direction from T to U. From T to U, we go through 30, which is sort of the middle length side. So starting at Q, going through that same middle length side, we get to P. So P goes next. So either way, you know that P goes next. And once you have the first two, the third one is whatever's left. We did Q, we did P, R is the last one. And that's the end of that problem. Let's keep going. For example, 2, it says determine if the following triangles are similar. If they are, write a similarity statement. Well, on this one, you've got to be a little bit more careful because you can look at the size of the numbers, but there's actually a faster way to do it. You can look at the two triangles as one inside of the other, and the corresponding sides are actually going to be in the same, basically, place as the rest of them. So, for example, if you look at TB, so if you look at this side TB, it has to correspond with T all the way to U. Okay, starting at the same point T, going all the way to U. So that's 8 corresponding with T all the way to U, which is 10 plus 8. You're going to add these two values together, these two lengths together, right? So that's going to be 10 plus 8, which is going to be 18. If we look at the bottom where we have TC and TV, so TC, actually let me notate this differently. TC is going to correspond with T all the way to V. Well, we already have T all the way to V. Okay, that's 13. We already have that. But we don't have TC. So to find that missing TC, you just take your whole length of 13, which is TV, and subtract the 7, which is the CV, right? And that's going to give you your value of TC. So that's going to be 13 minus 7, which is 6. So that's going to be 6. So those two correspond. Last but not least, we have our BC side. So our BC side. And that corresponds with the one that looks like it's parallel to it, right? Which is going to be this UV side over here. So the BC side corresponds with the UV side. So it's going to be 25 and 12. Now, when we make our ratios, just make sure you're consistent. So if you want to put everything from the small triangle on top, that would be all of these numbers inside. So it'd be 8, 12, and 6. If you want to do everything from the bigger triangle, that would be the outside numbers. That would be 18 and 25 and 13. Just be consistent. So for me, I'm just going to put everything in the big triangle on top and the small triangle on the bottom. Okay, so that means, for example, I could start with 18, which corresponds to 8. I'm going to divide that, see what I get. So 18 divided by 8. I'm checking in my calculator. So 18 divided by 8 is going to give me 2.25. And then I'm going to do it again. I'm going to go ahead and go next to 25 over 12. Okay, so 25 over 12. And that's going to be 2.083 repeating. Well, that is different. It's not much different, but it is different than the other one, which means these, even though they look like they could be similar, looks like they're the same shape, different sizes, they're not. Okay, they are not, since those ratios are not equal. So I'm going to say they are not similar. because the ratios are not equal. Okay? So in that case, there is no similarity statement. I'm going to cross it out. No similarity statement. If they are not similar, there is no similarity statement. Okay, example 3, let's keep going. So example 3 says determine if the following triangles are similar. If they are, write a similarity statement. Please notice that we don't have any sides labeled this time. We have no sides, which means we can't check ratios. What we can check is if there's corresponding angles that are of equal measure. Okay, so if we have 2 angles but not the third, just keep in mind that this third angle can be found just by adding the previous 2 angles, seeing what you get. So 63 plus 54 is going to give us 117 degrees, and subtracting that from 180. So this angle down here, angle L, is 180 minus 117, which is going to give us 63 degrees. Okay, so this angle is 63 degrees. We can do the same thing with our other triangle just to see what that third angle is. So to find this angle, we'll add 56 plus 61, which will be 117 again. So we're actually going to do the same math here and get 63 degrees again. Okay, because when I add those, I get 117 again. All right, so this is 63 degrees. Now, in order for them to be similar, I need to be able to find 3 pairs of corresponding angles. For example, I know that angle S and angle L could correspond because they're both 63 degrees. But I don't have an angle that corresponds with K because K is 54 and there is no 54. I also don't have an angle that corresponds with J because it's 63 and we have a 61 left, right? So because not all 3 angles have a corresponding angle that's the same measure, they are not similar. So not similar. I'm just going to say not all corresponding angles. Not all corresponding angles are the same. That's a good way to word it, okay? Some of them are, one of them is, right? One pair is, but they aren't all. That means, there is no similarity statement because they are not similar. Last but not least, example 4. Determine if the following triangles are similar. If they are, write a similarity statement. Again, I can't use the ratios like I did in examples 1 and 2 because I have angles this time. But I can look at the angles. So what I notice is that I have, for triangle EFG, I have a 65 and a 49. I can find the third one so we can just visually see what these angles are. So it looks like I have 65 plus 49. And I'm going to subtract that from 180. So that's 114. So this is going to be 180 minus 114. And again, it's 114 because those two add to 114. And that's going to give us 66 degrees. So that's G, 66 degrees. And then similarly, we can do the same thing down here. But you can see it's going to be the same number, right? 65 plus 49 is still 114. So when you subtract from 180, you're still getting 66 degrees, right? So now we can compare. I have the 66 with 66. I have 49 with 49. I have 65 with 65. So I have 3 pairs of corresponding congruent angles, angles that are the same measure, okay? So that means that they are similar. They are similar because all corresponding angles are equal. Okay, so they are similar because all corresponding angles are equal. So the similarity statement here is going to be very easy. Just name your first triangle. I'm going to go EFG. The one at the top is similar to triangle. Don't forget your second triangle. And then E is the angle with a 49 degree, right? And that is going to correspond with the other 49, which is R. So angle R. And then F has a 65 degree. That's going to correspond with Q. And then RQ, and the last one is going to be P, RQP. And that's it. Okay, thanks for watching. Have a good day.